A leaked video from Giga, Nevada just confirmed what the trucking industry feared most. Tesla's Semi-Gen 2 isn't just an upgrade, it's a complete game changer. Engineers caught on camera literally cheering as the truck smashed through 1.2 megawatts of charging power, a number no electric semi has ever touched. But here's what nobody's talking about. Why did DHL immediately double down and order more trucks after just one test? What did they discover during that 3,000-mile trial that made a logistics giant bet their entire fleet strategy on Elon's electric beast? Let's talk about what really happened during that DHL trial, because this is where everything clicks into place. Picture this: a global logistics company with decades of experience, known for being extremely cautious with new technology, loads up a Tesla Semi to 75,000 pounds and sends it on a 3,000-mile stress test. They're not just kicking the tires here, they're pushing this truck through real-world conditions, the kind that break promises and expose weaknesses. And what happened? The Semi delivered 390 miles on a single charge while cruising over 50 miles per hour the entire time. But here's the number that changed everything: 1.72 kilowatt hours per mile. Now, if you're not in the trucking business, that might sound like just another technical spec. But to fleet managers who live and die by fuel costs, that number is absolutely game-changing. In traditional trucking, you're constantly battling razor-thin margins, where a few cents per mile difference determines whether you're profitable or barely surviving. DHL saw those numbers and immediately understood something the rest of us are just starting to grasp. This isn't experimental technology anymore. This is the future showing up early, and it's cheaper to operate than what they're running now. When Zangler's drone caught footage of the Gen 2 at Giga, Nevada, the trucking community went wild over that Model Y light bar stretched across the front end. Some people dismissed it as Tesla just reusing parts to save money, but that misses the point entirely. Tesla is playing a much deeper game here. They know that fleet operators aren't Silicon Valley early adopters betting on cool factor. These are conservative buyers who need proven reliability before they'll commit millions to new equipment. By giving the Semi that familiar Tesla face, they're saying, this truck comes from the same engineering DNA that built the world's best-selling car 3 years running. That visual connection isn't vanity, it's smart psychology. But the real story lives under that skin, in the engineering improvements most people will never see. Tesla pushed efficiency to 1.7 kilowatt hours per mile, a 15% jump over the prototype. Let me put that in perspective. We're talking about an 82,000-pound machine moving down the highway, and Tesla found a way to squeeze 15% more distance from every unit of energy. That didn't come from one clever trick. It came from simultaneously reimagining the powertrain, smoothing the aerodynamics, upgrading the battery chemistry, and rewriting the control software. Each change compounds on the others. For a truck running 100,000 miles a year, that 15% efficiency improvement drops straight to the bottom line as tens of thousands in saved electricity costs. Scale that across a 100-truck fleet, and you're talking about millions in annual savings. This is where Tesla made their most controversial call, and honestly, it's the move that separates good engineering from great strategy. They ditched LFP batteries for 4,680 cells. Now, LFP made perfect sense for the prototypes. They're safer, cheaper, and last longer. But there's a brutal trade-off nobody talks about enough. LFP batteries are heavy for the energy they store, around 175 watt-hours per kilogram. To hit 500 miles of range, Tesla had to pack in a massive 900 kilowatt-hour battery. That weight is a killer in commercial trucking because federal law caps total vehicle weight at 80,000 pounds. Every pound you dedicate to batteries is a pound of paying cargo you can't carry. Think about the economics for a second. 2 identical trucks, same route, same fuel costs, but one can carry 5,000 pounds more cargo because its batteries weigh less. That truck makes more money on every single trip without spending an extra dollar on operation. Over a year, over a fleet, those numbers become absolutely massive. That's why Tesla switched to 4680 cells with nearly double the energy density. They can maintain 500 miles of range with a significantly lighter battery pack. The weight savings translate directly into payload capacity, which means more revenue per mile. Now, some people asked why Tesla didn't push for 600 or 700 miles with the better batteries. Here's where you see Tesla actually understanding their customer instead of just chasing impressive specs. Fleet operators don't need maximum theoretical range. They need practical economics that work every single day. By keeping range at 500 miles but cutting battery weight, Tesla simultaneously boosted payload capacity and lowered manufacturing costs. DHL's response tells you everything about whether that was the right call. They didn't just keep their original order. They came back asking for more trucks. Then there's that charging breakthrough, and the video of Tesla's engineers celebrating says more than any press release ever could. When the Semi hit 1.2 megawatts at the Megacharger station, those weren't polite golf claps. Those were genuine eruptions of excitement from people who understood they'd just done something nobody else in the world has accomplished. No electric truck anywhere has demonstrated this kind of charging speed. Most electric cars charge at 50 to 150 kilowatts. The Semi is pulling 1,200 kilowatts. That's not an incremental improvement. That's a complete reimagining of what's possible. Here's why this matters so much. In diesel trucking, you pull into a truck stop, fill up in 15 minutes, and you're back on the road for another 500 miles. Early electric trucks killed that rhythm. You'd sit for hours waiting to charge, completely destroying your delivery schedule. With 1.2 megawatt charging, the Semi adds hundreds of kilowatt hours during the 30-minute rest break that drivers are legally required to take anyway. The truck charges during mandatory downtime, not in addition to it. Suddenly, electric isn't just viable. In some scenarios, it's actually more operationally efficient than diesel. And there's another layer here that most analysts are completely missing. By enabling ultra-fast charging, Tesla changed the entire equation for battery sizing. They don't need to build trucks with massive battery packs capable of running 800 miles because the truck can recharge quickly during normal operations. Smaller battery means lighter vehicle. Lighter vehicle means better efficiency and more payload capacity. More payload means better economics. Better economics means faster fleet adoption. It's a virtuous cycle where every advantage compounds on the others. The power specs tell their own story. The Semi pushes 800 kilowatts of drive power, roughly 1,070 horsepower. That's an insane number for a commercial truck. Most diesel Class 8 trucks run 400 to 600 horsepower. But comparing horsepower between diesel and electric misses the fundamental difference. Diesel engines hit peak power in a narrow RPM range. Below that, they're sluggish. Above it, they're inefficient. Electric motors deliver maximum torque instantly, from 0 RPM all the way through their range. A loaded Semi can accelerate smoothly from a dead stop, climb mountain grades without struggling, and merge onto highways with confidence. These are scenarios where diesel trucks often labor and strain. But here's what really blows my mind. Tesla is delivering 800 kilowatts of power while simultaneously achieving 1.7 kilowatt hours per mile efficiency. In traditional trucking, those goals oppose each other. You can have power or efficiency. Pick one. Tesla just proved that trade-off only exists in combustion physics, not in electric drivetrains. The Semi is more powerful and more efficient than diesel alternatives at the same time. Even the small changes reveal careful thinking. Those side windows that don't extend as far back anymore? The prototype's extended glass looked cool in photos, but provided almost zero functional benefit for drivers, while potentially creating drag and adding manufacturing complexity. Shortening them probably improved aerodynamics and simplified production without sacrificing useful visibility. The diamond-plate anti-slip surfaces on the entry steps might seem trivial when you're talking about megawatt charging and autonomous capability. But ask any driver about climbing into a cab during a rainstorm or in icy conditions. Slips and falls during entry represent real injury risks. These touches show Tesla is listening to people who actually live with these trucks daily. That camera near the front wheel, though, that's the piece that could genuinely transform the entire industry. Tesla is clearly building toward full autonomy, and the timing couldn't be better. The trucking industry is facing a catastrophic driver shortage. The American Trucking Association's estimates we're short about 80,000 drivers right now, with that gap expected to double within a decade as experienced drivers retire faster than new ones enter the profession. If Tesla deploys even highway-only autonomy, they're solving one of logistics' most expensive and intractable problems. An autonomous semi could operate almost continuously, stopping only for 30-minute charging sessions, without the hours of service limits that restrict human drivers. The manufacturing context gives me real confidence in Tesla's timeline. Giga Nevada just hit 6 million drive units produced. This facility has been Tesla's backbone for years, building battery packs and powertrains that go into Model 3s and Model Ys across the country. Tesla isn't starting from scratch here. They're leveraging proven processes, established supply chains, and experienced workers. That significantly de-risks the production ramp and makes early 2026 production actually believable instead of just aspirational. Tesla plans to start Semi-Gen 2 production in the first half of 2026, ramping to full capacity by year-end. After years of delays, skepticism is understandable. But watch what DHL did. They ran a brutal, real-world trial, saw the numbers, and immediately committed to buying more trucks beyond their original order. Global logistics companies don't do that for publicity. They do it because the financial case is overwhelming and they want to lock in production slots before everyone else figures out what they already know. The question isn't whether this truck works anymore. DHL proved it does. The question is whether Tesla can build them at scale while keeping costs low enough that the efficiency advantage translates into real profit for fleet operators. If they pull that off, we're watching the fastest technology transition in commercial vehicle history unfold in real time. So here's what DHL discovered that answers everything. They didn't just find a truck that works, they found a truck that makes more money than diesel. That 1.72 kilowatt hours per mile efficiency, combined with 1.2 megawatt charging and increased payload capacity, means electric trucking is now more profitable per mile than traditional diesel. Not someday, today. That's exactly why DHL immediately ordered more trucks after just one trial. They ran the numbers, saw the future, and they're moving fast before the rest of the industry wakes up. This is the tipping point we've been waiting for. When the economics flip this decisively, adoption doesn't happen gradually, it happens in a rush. Tesla starts production in early 2026, and every freight company watching DHL's results is about to realize they can't afford to wait. If you found this breakdown valuable, hit that like button and drop a comment. What happens when every major carrier sees these efficiency numbers? Subscribe to Tesla Zone and turn on notifications because we're tracking every development as this transition accelerates. The Semi-Gen 2 just proved the electric trucking revolution isn't coming. It's already here. Some companies just haven't checked their fuel receipts lately.